All right. Today we're going to talk about human communication. We're sort of going to focus on humans. I think most of you are humans, so I feel like that's going to be an important species to talk about, right? Some of you may not be, that's fine. Some of these things will maybe apply to other species, but they've got some unique ways to communicate too. We definitely want to talk about language production and comprehension. Okay. There are some brain mechanisms that are going to be really important for us to discuss. Part of understanding this and having a sort of a deeper idea of what's happening is for us to talk about disorders of language production and comprehension, and also disorders of reading and writing. Language and communication are very important, right? In case you didn't realize, humans are a social species. We live in contact with other members of our species, right, Olivia? This happens all the time. You're in contact, whether you want it to be or not, with other members of your species right now, right, in this very class. And your ability to communicate with them is important, okay? So you want to be an effective communicator. You want to make sure that your ideas are conveyed. And I don't mean like you have to be an excellent writer or you have to be excellent at giving speeches, right? But at some basic level, we need to be able to convey our intentions, our concerns. We need to be able to get information to someone else so that they can use that, right? We cannot necessarily rely solely on facial expressions. We talked about facial expressions, right? When we talked about emotion. Okay? But facial expressions alone will not convey all of the information that we need. Now, language is much more than just speech, right? So what we think about speech typically. It's anything that's written, symbolic, or gestures, right? So we're going to talk later about sign languages, for example, and how that plays into this sort of idea as well. There are some major brain regions we're going to talk about. Broca's area, Wernicke's area, and then, of course, auditory cortex. All of these are going to be highly involved in the comprehension and production of speech and language. Just to give you an idea where these brain regions are located, Broca's area is sort of here toward the front near motor cortex. Wernicke's area is more toward the back, sort of at that intersection between some of your sensory cortex regions and parietal cortex. And then auditory cortex is kind of, you think about half of your brain as a fist, right? Your thumb, which would sort of go along this area. That's where auditory cortex is located, sort of down inside of that as well. So if you sort of pull that thumb back, there's an area in there called insular cortex. Your auditory cortex dips down into that area as well. Now there are some things we want to think about before we get into studying and thinking about language production and comprehension. One of those are what we call cerebrovascular accidents. These result from brain damage, okay, due to either an occlusion or a rupture of a blood vessel. Okay? So the end result is that we're going to decrease blood flow to a particular area. We're not going to be delivering nutrients. We can cause some other effects as well because we're increasing pressure, right, if the blood is spilling out into other parts of your brain. We'll talk much more about cerebrovascular accidents later this semester when we talk about neurological disorders and so forth. If there is brain damage in the right regions, this can lead to what we call aphasias. Okay? This is difficulty producing or comprehending speech. It is not because of deafness or motor deficits. Okay? This is not because someone has damage to their auditory structures, right? So we're talking about brain damage, not damage to your your cochlea or damage to your eardrum, auditory ossicles, things like that. This is not a production issue because someone has difficulty moving muscles that control their sort of voice production areas, right? So your mouth, larynx, tongue, so forth. Right? Many of you probably know someone who's had a motor cortex stroke, right? It's affected part of their body. They may have some slurred speech because of that. That is not an aphasia. right? That's a motor deficit that's keeping them from producing speech, in that it's keeping their mouths from moving appropriately, not related to their ability to produce or comprehend speech in the same way that we're thinking about with aphasias. Okay. The other thing that's kind of cool about this is what we call lateralization. Okay? And I want you to think about your hemisphere. You have two hemispheres, right? And we've already talked a little bit about the right hemisphere being more involved in emotional content, right? In this case, for most of you, language is going to be in your left hemisphere primarily, right? Is anybody left-handed? We've had this sort of discussion briefly, right? So for those, really just the two of you, right? Is that it? Okay, great, that's fine. It's still highly likely that language is on your left side, right? There's a slight chance it could be somewhere else, like over on the right side, but for most people, even if they're left-handed, language is still isolated to the left hemisphere, right? So when we talk about brain damage producing problems with speech comprehension and understanding, we're typically talking about left hemisphere damage, okay? We're not going to talk about right hemisphere damage as much, although we'll think about that a little bit when we think about your ability to understand and comprehend sort of the emotional aspects of speech, right? Some of that's going to be, because remember, right side is more focused on emotional content, at least in this case, okay? Not a big deal. So when we think about language comprehension, we want to think about what we call our mental lexicon, right? In our brains, we store, in our memory stores, sort of an understanding and a connection, right, to all of the words that we hear. And when we hear those words, we need to access that meaning. We need to string those meanings together, right, so we can comprehend the entire content of the message that's being delivered. A lot of this is going to involve an area called Wernicke's area. We'll talk about Carl Wernicke later and the important part of his work. Anybody bilingual? I know there should be at least one hand that goes up. And two hands, awesome, that's great. And they were on different people, so that's always phenomenal. Sometimes people will raise both of their hands. It happens. Anybody more than bilingual? Trilingual? Quadlingual? How far do I need to go? Trilingual, quadlingual? How many languages? 12? We can count down from there.
10.
10?
I'm kidding.
You're kidding. Some people do speak multiple languages. What's really interesting about this is folks who are bilingual, they seem to have an increase in the density of their left parietal cortex. That's kind of exciting. There are some areas of your brain that are responsible for, that are common to both languages, and then some regions that are specific to a particular language, right? And so that's kind of cool. There's actually, well, we'll see that image in a moment. We also want to think about, again, these sort of rhythmic, emphatic, and melodic aspects of this, right? So a lot of this is going to happen in your right hemisphere, again, because this can be emotional content. How many of you can recognize other people's voices? That's exciting, right? You're like, hey, I know that person. Hang up the phone. Or, hey, I can hear someone around the corner turn the other way. Anybody ever done that? Happens all the time. Don't worry about it. Some people have right hemisphere damage. Again, this is one of those rare exceptions where we're thinking about the right hemisphere, not the left hemisphere. And they'll actually lose the ability to recognize other people's voices. Which would be really strange, right? Because then you're going to be talking and it's like, I don't really know if that's your voice or not. Like maybe you think someone's constantly doing a ventriloquism act. Right? So, like Eric, if you started talking, I think, wow, I'll recognize Eric's voice. But I'm not going to recognize that it's actually your voice coming out of you. I'll recognize your mouth is moving and I hear a voice. It's going to be weird. And if it's over the phone, somebody will say, hey, it's me. You have no idea who it is. So there you go. This is your mental lexicon, so we talked about that briefly. Here again, you have Broca's area. That's going to be a speech production area. We need to get information from there, or to there, from the what we call the posterior language area and Wernicke's area. And these are going to help us access those memories and perceptions, which means that's the meaning of the words. Okay, so we're going to understand that information. And then we can pass that information to Broca's area so that we can create a reasonable response to that, right? So we can reply appropriately to that information. So, don't worry about metaphors. How many of you understand metaphors? Nobody does. I know that. I talk to you every day, and I know your metaphorical reasoning is lacking, so you guys should work on that. What you should do to help is, like, if you see right here, it's this part of your brain in the right hemisphere that's involved. You should, like, rub that side of your head a little bit to try to wake up that part of your brain so you can do better on these, like, tests, right? So when you take these tests that are like the SAT, right? And it's always like cupcake is to rabbit as bananas are to, and then you've got to, like, fill in the blank with something. I just made up, like, some words there. That's a metaphor, right? You think about metaphorical understanding. So when somebody writes something and they will say, you know, they try to give you some sort of abstract understanding of a concept, and they use metaphorical language when they write or when they speak, then you're going to use your right hemisphere for that, not the rest of your brain, even though the left side is mostly involved in speech. Not a big deal. All right, here you go. So this is someone who is a 31-year-old bilingual English-French right-handed patient. That's important because, again, we're thinking about the possible, you know, flips there. This person had a small brain tumor that had to be removed. What was really interesting is they typically will not anesthetize you during a brain surgery, right? And the reason for that is they don't want to, like, scoop out the wrong thing. So they'll just kind of, like, gently cut around, and if for some reason you, like, lose some function, they'll go, "Whoops, sorry," and they'll try to, like, glue it back together. It's not exactly how they go about it, but in general, that's a general approach. So what they can do is they can do some cool research, though, right? And so they'll say, like, "Hey, you know, why don't you, you know, answer some questions, talk to us in English or in French?" So that's kind of cool, right? And then they'll, like, I love how they, like, right on the surface of this guy's brain, they just, like, stick these little paper tabs with letters on them. I don't know how sanitary that is. They're just like, I'm just going to stick a paper label right here on your brain. That's going to be awesome. And then they put these fun little flags here too, right? So you've got your English flag and then your French flag. And what's kind of interesting, French was actually his native language, so he learned French first. And you can see here are a couple regions that were active when this individual would speak French. And here's a region that was active when that individual would speak English, right? And you see there is some overlap. You know, this particular region here is sort of the same, but then there are some areas that are specific just to the sort of French language for this individual. Does that make sense? So that's kind of cool, right? I don't know. I was excited by that. That means, potentially, Eric, this person could lose the ability to produce one language and not the other. Right? If that damage was in, you know, one particular place, they might lose the ability to produce or comprehend only French or only English, and not both languages, because there are these sort of separate regions, but also overlapping regions. This, again, are those elements of speech that are sort of, I don't want to say nonverbal, but the emotional, you know, sort of rhythmic components. How many of you have heard someone speak in a foreign language that you don't understand, but yet you sort of get the idea behind that, right? You can understand if someone's angry, you can understand if someone's happy, right? And you can do that just by hearing. You don't have to see any other body language, but you can kind of extract that from the from the speech itself. So again, your right hemisphere is going to be more highly involved in that, and that's because, again, your right hemisphere is more involved in emotional content than your left hemisphere. All right, let's talk about a specific type of aphasia. This is going to be called Broca's aphasia. We're going to call it Broca's aphasia because that's what Broca decided he was going to call it when he described it. So if you discover a new sort of neurological disorder, you get to name it after yourself, so that's exciting. So always be on the lookout for that. Broca, in case you have forgotten, Broca was the French, right, neurosurgeon. Folks would come into him with brain damage. He would ask them a bunch of questions. There would be things they couldn't do, and then later when they died, he would cut open their heads and go like, look, you're missing this part of your brain. That's the speaking part. You couldn't speak, you missed that part of your brain, and then we go like, oh, that's Broca's area. So, Broca's aphasia, and there's some variation here, so I want to step back, and I want to give you this sort of broad overview of sort of the problems with this general approach, right? How many of you think we could create a speech production problem in a rat? Well, rats don't talk. Okay, in case you, I'm just, that's new information for you, but rats don't talk. So recreating this in a non-human animal is going to be difficult, right? Because as far as we know, non-human animals don't use speech and language in the same way that we do. Now, they have other ways of communicating, and you might think, well, we can see some deficits there potentially, right? But that's going to be really hard for us to measure, okay? So we really have to look at human studies. There are not a lot of humans signing up going, you know what I'd really love you to do? Just scoop out just my Broca's area. And then see if I can produce speech. And just continue to do this. So we don't have these really well-controlled ways. Well, we don't have any well-controlled way of damaging human brains that people will let us use. We do have some methods we can do that. So we're relying on people who've had those cerebrovascular accidents, right? And so what I'd like for you all to do is go out and try to have a stroke. But just have a stroke that damages your Broca's area and nothing else, right? Where you can just that one place, okay? It's impossible, right? You're going to have peripheral damage. You're going to have damage elsewhere. So when we start to describe some of the characteristics of these different sort of problems that humans face, Chloe, there's always this variability in symptoms because someone may have a bigger lesion caused by their brain damage. Someone's brain damage might be shifted forward or backward or up or down a little bit in their brain, and it might incorporate a different area, right? So we really have to look at a lot of patients across many cases and try to pool all of that information together and say, this is the particular brain region, and these are the symptoms, okay? So sometimes the reason I tell you that is sometimes you will hear sort of conflicting symptoms for these different types of aphasias. But Broca's aphasia, typically we're going to have slow, it's going to be labored, non-fluent speech. Okay. Their comprehension is actually going to be quite well. It's going to work well. No problems there typically. They're going to have difficulty with what we call function words, and these are sort of grammar words. They're fine with what we call content words. Nouns, verbs, adjectives, right? And so we have this sort of picture here. This is a standard picture to assess aphasias. We're going to ask someone to describe this scene. And if I were to ask most of you, you would say, well, it looks like the mom or the babysitter is sort of absent-minded and she's washing some dishes, the sink's overrunning. Looks like that boy's about to fall off that sort of stool. His sister's, that's clearly his older sister who's demanding cookies, right? And has convinced him to climb up that rickety stool because that's what older siblings do. You always put your younger siblings at peril so that you can get the rewards. And if any of you are not an older sibling, I apologize on behalf of all of us who have made our younger siblings do crazy things just so we could get something. So that's how most of us would describe this. An individual with Broca's aphasia, they would not be able to create that sort of coherent, that was a fairly coherent description, right, of this particular image. They would say things that would be sink, fall, dishes, boy, hurt, right? All of those are content words. And if you had just those string of content words, you could probably put something together and figure out what's going on, right? It's kind of like, I don't know, this is, Eric, maybe just for you, sort of kind of like talking to Lassie, right? You know, and there's like, you know, Lassie's barking something at this boy, and Lassie is this dog who's not able to put together, right? Regan, you know Lassie, right? Not able to put together this like coherent string of words, but it's like boy, well, danger, right? And so they're like, oh, right, Lassie, there's a boy in a well, we'll go get him out of danger. So that seems exciting. Now, the problem with that is that can be very difficult, right? It can take some time. So these folks are going to have difficulty getting out function words. They're going to do okay with content words. They're going to display what we call agrammatism. They're not going to use grammar at all. So they're not going to put this in any sort of normal set of rules, right, or behaviors, right? So the string of words they use, they're not going to be connected in the way that we would form a sentence. Okay? They're also going to have difficulty finding a word. This is called anomia. All right. They may, if they wanted to say overrunning sink, right? And they might have some difficulty with that. So they're going to sink. They might not come up with sink though. Basin, you know, water, spigot, faucet. I don't know. They're going to have difficulty finding the words they want to use. It's going to be a lot of delays, and then they're not going to have those connecting sort of content words. The information is going to be there, so they clearly understand the task, right? So if you have someone with Broca's aphasia and you say, hey, describe to me the content of this image, if they give you words, boy, danger, cookie, sink, dishes, you understand someone's looking at that, right? And they understand what you want them to do. You can ask someone with Broca's aphasia to do something. Hey, you know, walk over and kick the door. So someone with Broca's aphasia will go, kick the door. They understand speech. They're just not able to produce fluent speech. Not too big of a deal there. Wernicke's aphasia, on the other hand, is much different. Individuals with Wernicke's aphasia are able to create fluent speech. They are able to follow grammatical rules. They are not able to understand what you've said to them or to create a sentence that makes sense. It would make your English teacher happy in the sense that it would have nouns and verbs and prepositions and it would all go in an order that would make sense, but the content doesn't make any sense. So they say something like, the chair ate a pickle. I don't know, right? I mean, that makes some sense, right? I mean, there's a noun, there's a verb, something's happening. Chairs don't eat pickles, right? They'll just plug in random nouns and verbs in a sentence. It will come out fluent. So they're not gonna have any comprehension on what's going on. They have really, apparently, difficult time converting thoughts into words. We're never gonna know that. The reason we don't know that is we can't ask them. And if we could, we can't ask them, right? You can say, hey, what are you thinking right now? And they know that you've said something, and they'll reply to you, again, with a, Travis, perfectly well-constructed sentence that is not in any way, as far as you can tell, related to your question. Right? It's going to be difficult. So I'm just thinking right now, someone left this room, and people have, and you're allowed to do that. But I'm thinking like at some point I'm going to catch someone gone, and then I'm going to say class is over and try to get everyone out as quickly as possible so that when they come back, the room is empty. Does anybody think that might be entertaining? I think it would be. All right, speech sounds, don't worry about this too much, not a big deal. Hey, who remembers mirror neurons? Yeah, those were something, right? Mirror neurons are also going to be involved in speech production. It's not surprising. Here is Wernicke's aphasia, right? Again, we're going to have damage to Wernicke's area. We're going to have a difficult time accessing all of those memories and perceptions, right? It's going to be, we're not going to be able to access that information. And when we can't access that information, there's not much we can do with it. Right? We can't really put that together in a way that's going to be going to make any sense to us when we try to produce that speech. Don't worry too much about conduction aphasia. It's not too much of an issue here. But it is, again, it is related, similarly it's related to accessing those, that mental lexicon. All right. What about folks who are deaf? Okay. And they'll, at least in the United States, they'll use American Sign Language, right? That's a pretty common sign language. What's really interesting is that individuals with hearing deficits who use this, or individuals without hearing deficits use this, they still use Broca's area. They still use mirror neurons, right? Same as you would for anything else. Right hemisphere is going to be involved for the emotional components of that, same as you would have for spoken language, right? It doesn't matter. It's still language, right? We're still conveying ideas in some sort of symbolic or abstract way. What's also interesting is individuals who have Broca's aphasia or Wernicke's aphasia, if they use sign language, we see the same symptoms in their ability to sign that we would see in someone's ability to speak. So if someone has Broca's aphasia and they communicate with sign language, they're going to give you content words. They're not going to give you any function words. They're going to have a difficult time producing those signs. There are going to be delays, right? Same as you would see with the spoken word. If it's Wernicke's aphasia, they'll be able to sign perfectly smoothly. But what they say or what they sign is not going to be related to their, or at least as far as we can tell, to their environment. It's kind of interesting, right? That was pretty cool. All right, let's talk about stuttering a little bit, right? This is sort of interesting. Frequent pauses, prolongations of sounds. I think we've all heard someone who stuttered. Primarily, this is just a repetition of sounds or syllables. It's going to disrupt that normal flow of speech, right? So, individuals who stutter, if you were to use some brain imaging techniques with these individuals, you would see that there's decreased white matter beneath the ventral premotor cortex. Not a big deal. What's really interesting about this white matter is actually involved in taking your auditory feedback and integrating that with planning your own speech, right? How many of you have ever wanted to say something? Has that ever happened to anybody? A couple people. That's fine. When you want to say something, at least I'm told that this is what you should do. You should think before you speak. I don't know. I'll let you know how that works out when I decide to try it. But most people, Michaela, should think before they speak, right? So you have some idea of the words you're going to say, okay? How do you know you've said them? You can hear them, right? Okay? You can hear your own voice when you speak, right? And that's perfectly normal. If for some reason that auditory feedback was disrupted and you were not able to hear your own voice as you were creating it, you might decide that it's important for you to repeat that particular syllable or that particular word until you know you've heard it so you can move on to the rest of your sentence, right? So if you were trying to say the dog won the race, and for some reason when you got to the word dog, you didn't hear the word dog, so you would repeat it, right? And you would continue to repeat it until you hear the word dog so you could move on. That's what's going on in folks who stutter. They're not getting that auditory feedback to let them know, hey, you've said this. They have to keep repeating it until they get that feedback, and then they can move on to the rest of their statement. It's kind of cool. Not a big deal. This is a nice chart in case you want to have a breakdown of all of the types of aphasias we've talked about. We should talk briefly about reading and writing. Let's see. How much of this here? Oh yeah, we can finish this chapter today. That'd be awesome, right? How many of you are excited about that? Great. It's going to happen anyway, so you might as well be excited. Reading and writing, what's its relationship to aphasia? Typically, your reading and writing skills are going to mirror your speaking and comprehending abilities, okay? So if you have difficulty comprehending speech, you're going to have difficulty reading as well. If we think about reading briefly, there are sort of two approaches to reading. There is whole word reading, right? And this is what we think about like sight words. And then there is what we call phonetic reading, where we sort of sound out the words, right? So we have to do this. There are different kinds of dyslexias, right? So there's like surface dyslexia. You can read words phonetically. You're going to have a lot of trouble with irregularly spelled words. Okay? How many of you know about the word enough? E-N-O-U-G-H, right? Enough, right? If you were to try to sound that out, right, and follow some phonetic rules, you're not going to come out with enough, right? It's one of these weird sort of exceptions. Reminds me of this time I was working with a lab mate of mine. He was from China, and we were trying to find this filament for this device we had. It was like a heating filament. There were two kinds. There's like a box, and there's another kind he referred to as a TRO filament, which I had no idea what a TRO was at all. And I was like, I cannot help you because I don't know what a TRO is. And he said TRO, and so he wrote it down for me, T-R-O-U-G-H, which is a trough. And I was like, oh, I know exactly what a trough is, and I can definitely help you make that. So again, it's one of those irregularly spelled words, right? So if you try to use the whole word reading method, or the phonetic method, it's going to be difficult. So there you go. Again, direct dyslexia, that's kind of where you can read words aloud, but you don't understand them. Okay? You can definitely read your familiar words, but not your ability to read phonetically. I should step back and say most of these that we're talking about are, a lot of these are going to be, especially if it's familiar words, it's going to be things, brain damage that happens at a later time, right? There are, of course, dyslexias that are coming from the beginning, but many of these are going to be related to brain damage later. Phonological dyslexia, that's when you can read by the whole word method, but you can't sound out words, right? That can be complicated as well. Now there is a good bit of plasticity in what we call the visual word form area. Okay, this helps us, recognize words as, or segments as words, right? In these characters. Again, there are developmental dyslexias, right? So these are different than the previous dyslexias that we talked about. And there are some genetic components there as well. Don't worry about that. Here's your types of reading, so you can do whole word or that phonetic reading, and there are two different kinds of approaches. Surface dyslexia, again, you can't do whole word reading, so you've got to go through the phonetic. That can be difficult. Again, for those like oddly spelled words that don't follow normal phonetic rules. There's phonological dyslexia. Don't worry too much about this or that. Dysgraphia is difficulty writing, right? So folks with dysgraphia, they will intend to write a sentence and then they will not be able to get out exactly what they were trying to say. They can go back and read that sentence and realize, whoa, that's not exactly what I meant at all. That sentence had a lot of problems to it. So if you have dysgraphia, you'd have to go through multiple editing processes, read your paper many, many times to get that to the level where other folks could comprehend that. Some nice charts. I believe that's everything. Any questions?